Okay, so today we're going to be going over the questions that are on your Chapter 4 test. So we're going to do a little review. There's only 9 questions. So first thing you're going to want to make sure you have is your formula sheet, your unit circle, your reference angle, graphic organizer, all of the helpful tools that you're going to want handy. So let's start with our first couple questions, which are on reference angles. So the first thing you want to do is figure out what quadrant you're in. So 171 is in the second quadrant. And if you look at your reference angle formulas, the second quadrant formula is 180 minus theta. And our theta is 171. So that would give us a reference angle of 9 degrees. Now, an easy way to check your answer should be between 0 and 90. Okay, number 2, 343 degrees. That is in the fourth quadrant. And the formula for a reference angle in the fourth quadrant is 360 minus theta. So 360 minus 343 degrees is 17 degrees. Okay, now one thing to consider when you do a reference angle is if you have a negative angle, the easiest way to fix that is to just add 360 to it first and then find your reference angle from there. Okay, so let's look at number 3 next. Number 3, we have a right triangle over here. We're going to find the exact values of the 6 trig functions. So first thing I'm going to do is find the missing side here, and I'm going to use the Pythagorean theorem to do that. So I have 2 squared plus b squared equals 10 squared. So this is 4 plus b squared equals 100. B squared is 96. And then I take the square root of that. Now the square root of 96 actually simplifies down to 4 root 6. So I'm going to label this side down here 4 root 6. Okay, so let's make a list of our 6 trig functions. So I'm going to start with making a list. I'm going to do sine, cosine, and tangent. Here's my angle theta. So sine would be opposite over hypotenuse, so 2 over 10, which simplifies to 1/5. Cosine is adjacent over hypotenuse, so 4 root 6 over 10. Outside numbers we can simplify, so that's 2 root 6 over 5. And then for tangent, opposite over adjacent, so 2 over 4 root 6. Which simplifies to 1 over 2 root 6. And that simplifies if I multiply the top and bottom by root 6. Root 6 over 6 times 2 is 12. Okay, next up, let's do the other 3 trig functions, so the reciprocals. And these are on your formula sheet. So we have cosecant. Reciprocal of 1/5 is 5. We've got secant. So that would be 5 over 2 root 6. So if I multiply the bottom and top by root 6, I get 5 root 6 over 6 times 2 is 12. And then cosecant, 12 over root 6. So that gives me 12 root 6 over 6, and that reduces to 2 root 6. Okay, next let's look at some graphs. So the first one I have here is -5/2 cosine of x over 4. So you're going to want to look at your formula sheet where at the very bottom where we listed the formula, y equals a cosine of k theta plus c. And we're going to want to compare it to that. So if we look at number 4, our amplitude is the number out in front, so I'm going to make a list over here. Our amplitude is 5/2. That negative means we have an x-axis reflection. Okay, so let's do the period. Period for cosine is 360 over k. Now k is the number out in front, which should be 1/4. So 360 divided by 1/4 is 1440. So when I set up my chart here, I want to make sure I go all the way to 1440. And I always mark halfway so I can figure out where half of the graph is going to be. So 720 would be halfway. I've got to go up to my amplitude, so 5/2. So I'm going to go up to 3, down to -3. Now over here on the side, I'm going to draw a quick cosine graph. So cosine normally looks like this. So I'm going to be making that shape. The problem is that I have an x-axis reflection. So instead of starting at 1, I'm going to flip it. It's going to look more like this now. So I'm going to make this red shape here. I'm going to start at -5/2, so -2.5. Go up to halfway at 720, and then I'm going to draw my other half. Now you only have to draw one period for these types of questions, and the next thing you should do is you should check it on your calculator. So if you go to your graph on your calculator and you type in -5/2 cosine of pi over 4. Make sure you're in radians. Now, if you hit graph, you're not going to see it all that well. Oop, I did not do zoom trig, so I've got to do that in a minute here after it's done graphing. So I'm going to do zoom trig. Zoom 7 is zoom trig. It's still looking funny. Let me go back to my y equals and make sure I typed it in right. Yep, I'm missing the x. So pi, oop, it's x over 4, not pi over 4. So x over 4. There we go. So it does not look like what we drew. It does, it's just the one part of it. So if you want to fix your window, we're in radians. So I'm going to have my x go from 0, now 1440 in radians. So that would be 1440 So I'm going to convert degrees to radians. This is a good review for that. So you're going to do pi over 180, right? That's the formula for converting degrees to radians. Now if we go to graph, we should see exactly what we drew. Yep, works perfect. Okay, so let's go on to our next graph, number 5. Okay, number 5, we have 4 sine of 2x minus pi. So I'm going to make my list again. I've got my amplitude is 4. My period, 360 over k, and k is 2. So that's 180. And phase shift I have on this one, negative c over k. So we've got negative pi over k, which is 2, so pi over 2. That's 90 degrees to the right. Okay, so I'm going to draw a little sketch of the sine graph, just so I know what the shape it makes. And you have your graphic organizer that we created in class. So here's what sine looks like. Now I'm going to make sure my period goes to 180, so I'm going to stretch this out a little bit. I'm going to put 180 at the end, 90 in the middle. I always mark off the middle too. I have an amplitude of 4. So I'm going to go up to 4, down to -4. So my shape is still going to look like this. I would be done by 180. So if I didn't have a phase shift, I would just go ahead. I would go up to 4, back down to 90, do the other part of the graph, end up at 180. The problem is I have a shift of 90 to the right. So instead of starting at 0, I'm going to start my graph at 45. I'm going to go up. Halfway would be between 90 and 180. Go down. And I'm going to end 90 degrees after 180, which means my graph really ends at 270. Now, another technique you could do is you could go from 0 to 45 and do a period that way and just cut it off here. That would be fine too. Okay, last part here, we have some inverses. So for these, you're going to want your unit circle out, and you're going to want to remember what sections the inverse functions work on. So I'm just going to make a list over here. For sine, we're going from -90 to 90. For cosine, 0 to 180. And for tangents, -90 to 90. So that helps us determine what quadrants we're looking in. Okay, so number 6 is weird because it says 4. Now 4 is not on our unit circle. If I go to do that on my calculator too, let me go back, inverse sine of 4, if I press enter, I get an error. And that's because the unit circle, remember, only goes out to 1. So 4 is not an option. We can write does not exist. Okay, number 7. Where is cosine -√3/2? Now I'm going to make sure I look at my chart here. Cosine inverse only exists from 0 to 180. So that's just the first and second quadrant. So that's the only quadrants I'm going to be looking in. So again, cosine is my x. In the first and second quadrant, cosine is equal to -√3/2 right here at 5 pi over 6. Okay, next up, number 8. This is where we work from the inside out to the outside. So just like with the top, I'm going to solve this first. I'm going to find where tangent inverse, so where tangent equals -1. So tangent is only in the, if I look at my chart over here, the fourth and first quadrant. So I'm going to get my chart out here. Negative, it's got to be down here. So sine over cosine, the only spot where I would get a 1 would be where they're the same, and here it's -1. Now I don't want to use 7 pi over 4 because that's not an angle between -90 and 90. So instead of writing it as 7 pi over 4, it's in the same spot as pi over 4. So I'm going to write it as -pi over 4. And I'm going to bring down the cosine. So now I'm going to evaluate the cosine of -pi over 4. So I'm going to get that chart out again. -pi over 4 is in the same spot as 7 pi over 4, and I just want cosine. Cosine is the x, so that would be √2/2. And the last one, number 9, is pretty easy, right? This is the opposite rule. Cosine and arc cosine just cancel each other out, and as long as this is an angle or a value that is in our domain or range, a -0.3 is a possible answer. It's between -1 and 1, so this is our answer, -0.3. Okay, so if you need to rewatch anything, make sure you go back and redo the problems as many times as you need.